Hey, Nathan here from PH Studios, and welcome back to another networking tutorial. It's been a little while since we did a networking tutorial. I apologize for that. It's just been the time for holidays. I took the Thanksgiving weekend off. Then I had to do some other tutorials, those that were planned for that weekend, but I just took that weekend off for Thanksgiving, so I hope you had a nice Thanksgiving weekend if you celebrate that. If you don't, I hope you had a nice weekend in general. So anyway, let's get a few networking tutorials done before the Christmas holidays and the end of the year, which I'll be spending most of my time doing the tower defense. So last time we worried about the bullets, and this time I think we're going to do the SpawnPool, if I remember correctly. So the SpawnPool was built on the particle system, and I'm just gonna go ahead and drag and drop that SpawnPool in there. It's in the library, and it's a SpawnPool here. So I'm gonna drag and drop that. I'm gonna copy the class, and don't worry, I'll go over it in great detail. I'm just copying and pasting it. So anyway, in the simple networking game, let's go ahead and right-click the project and go to add new item. It is outside of the recording screen, but there is a new item, and then in the class we want to call it, if my mouse would work, SpawnPool.cs. Go ahead and cut that and write the code I have here. So it's going to be public class SpawnPool less than sign, capital T, greater than sign, space, the word where, space, capital T, space, colon, space, the word new, and opening and closing parentheses. So now, what this does is we are using generics at this point. Now, what generics do is if we look at the game1.cs, we have already used generics in the past. If you look at the list, it's a list of gameplay objects. So that is using generics. It's telling the list that it's a type of gameplay objects, not ints, not bytes, not strings, not a list of TCP clients, just a list of gameplay objects. That is what we're doing for the SpawnPool. It's going to be a SpawnPool of whatever we decide. It can be a SpawnPool of... It has to be new, so it has to be able to have a constructor. So it's an object. So what we're going to use it for, it's just going to be a SpawnPool of gameplay objects. And that's going to hold our bullets. So you can modify this colon, and it can be a derivative of gameplay objects if you do not want any other class to worry about this. If you don't want it to be all objects, if you just wanted to narrow it down to gameplay objects, you can put where T is a derivative of a gameplay object. But anyway, that's beside the point. We are using generics that will allow us to make a SpawnPool of any type that has a constructor, so a object. Because we call the constructor here. Alright, so we have an int max items that we pass whenever we call the constructor, a int count, and then encapsulated is a queue of the same type, T, and it's an inactive queue. So all the items inside this queue are all inactive and are ready to be used. So when we call the constructor, it sets the max items and it creates a new inactive queue, and it automatically sets the maximum as max items. Then we call populate, which will actually enqueue into the queue new T for until it reaches the max items. So it will actually enqueue all the items right away, so you do not have to worry about adding items later. And then we just set the count to the max items. So how many inactive items are available is what the counts is referencing. So now, when we want to grab an object from the inactive list so we can use it, we need to call a release method, which returns to the type T. Now that will decrease the count because our inactive list is going to shrink. And then we call DQ from the built-in queue. And that will grab the object and will return it. Now, when we're done with that object, when we wanted to destroy it in the past, we want to save it later, we need to add it to the spawn pool again, which will increase the count, and then add it to the inactive queue. It'll enqueue it. So that's the spawn pool. Now, if we go to the game1.cs, let's go ahead and create the object of that spawn pool. So type in spawn pool, and it's going to be a type of gameplay objects. Spawn pool of gameplay objects, and let's call it bullets. Alright, so now inside of the initialize, right before base.initialize, go ahead and press enter twice to make a gap. And let's say bullets is equal to new spawn pool. And let's pass it, let's say 20 bullets maximum on the screen at once. And that might be pushing it. It might not even go close to 10, but it might as well be safe than sorry at this point. It's not going to take up that much memory. Alright, so we have bullets now. Now we can get to work. So, in the initialize, after we create the new spawn pool, let's call bullets.populate. So we can go ahead and populate the list. And it will create the 20 bullets right away, and then we can use them all later on. Alright, so let's go ahead and go to the process data, which at this point, we're going to create a bullet if client B fired a bullet. We need to create it on the client A side. So right now you see a gameplay object bullet is equal to new gameplay object. You want to keep that except for the new gameplay object. So delete new gameplay object. Now let's call bullets dot and then release. So we release an item from the inactive queue, and then we can use it later on. We modify the texture, and we actually modify the position, rotation, speed, and velocity. And then we add it to the enemy bullets list. So now it's outside of the spawn pool and inside of our enemy bullets list. It's active, it's on the screen, it's flying around. Now at that point, we need to remove it. So as you remember last time, I did not remove any of the bullets because we were going to anticipate that we were going to create a spawn pool. So when we do the for each loop, we loop through all the player bullets and loop through all the enemy bullets when it's past the sides of the screen. So right now, we only have it shooting from the top down or from the bottom up. So it can only pass the top side of the screen or the bottom side of the screen. So let's go ahead and test that out. If GameObject.position.y is less than 0, it is past the top of the screen. Now we need to remove it from the list. And there's several ways you can do this. If you want to do it inside of the for each loop, you might want to build a new list for each type, player and enemy, and call that a bullets to remove or something like that. So player bullets to remove, and then enemy bullets to remove. Now, the reason you do this is because you cannot directly modify the list as you're looping it through on the for each loop. So player bullets is equal to 1, or is equal to 10. Player bullets to remove is equal to new list, and it's going to be the same 10. Enemy bullets to remove is equal to new list, and that's going to be 10 as well. That was in the initialized. You already had the player bullets is equal to new and enemy bullets is equal to new. I just added the player bullets to remove and enemy bullets to remove. Alright, so the easiest way to do this is to add it to a bullets to remove list. Because you cannot directly modify this list if you're inside of the for each loop. It'll complain about that. Now, you can use a for loop and do all mathematics to go around it. Like if you remove the index, you, instead of increasing the index, like you do in a for loop typically, you can just set it back to the same thing, and then you can do all that trickery. Or you can just use a for each loop and do the way I'm doing. Either way, this one just creates more list references and all that stuff, but if you're not that worried about that, you can do it this way. Alright, so let's add it to a player bullets to remove .add game object. Alright, the bad thing about this way is you need to loop this list and remove it from this list, so you have to do 2 loops. Alright, so if the game object.position.y is less than 0, and we need to add on that to or game object dot rectangle dot bottom is greater than graphics device dot viewport dot height. So we get to the very bottom of our game window, and if the actually it would be rectangle dot top, I apologize for that. If our top of the rectangle, which means the very top of our texture, is below the very bottom of our gameplay screen, we can no longer see it, therefore we need to remove it from our list. Alright, so now we do the very same thing on the enemy bullets. So if game object.position.y is less than 0, or game object.rectangle.top is greater than graphics device.viewport.height. If that succeeds, we need to add it to the enemy bullets to remove. Add game object. Alright, so now, like I said, we need to loop those twice, loop those again, but we loop through the player's bullets to remove and enemy bullets to remove. So for each gameplay object, game object, in player bullets to remove. Then we need to actually remove it from this list and add it to the NQ as well, the spawn pool. So we call player bullets dot remove game object, and then spawn pool, which was bullets dot add game object. So we add it back to the spawn pool. Now we need to do the same thing with the other enemy bullets to remove. For each gameplay object, game object, in enemy bullets to remove, enemy bullets dot remove game object, and then bullets dot add game object. Now once those are done, we want to call player bullets to remove dot clear and enemy bullets to remove dot clear. Alright, so this might be a lot of work for you. If it is, you can just do what I mentioned before and do a for loop. So it'll be for int I is equal to 0, I just can't type at all. I is less than player bullets I++. Okay, so if you want to do a for loop, player bullets.count. There we go. So if I is less than player bullets.count. So when we do a for loop, we can get around this issue. So let's go, I'll just demonstrate this. But instead of using GameObject.update, we need to actually call player bullets sub, which is the bracket end bracket dot update. So instead of having a game object, we need to actually call it directly as a array, basically. Now at that point, if it is collided, we need to remove it from this list and then add it to the other list. So player bullets dot remove at I minus minus, and then we need to add it to the spawn pool again, which is bullets dot add, and then we add the object. So either way is fine, whichever one you prefer. This is a little bit more complicated according to when you think about it in mathematically. This is more complicated in that you need to add it to another list, and then you need to loop through that list to modify the list indirectly, basically. So whichever one you prefer. This one is cleaner in some ways than this one. So let me just do this. I'll delete this one, and then delete the player's bullets to remove one. So that way two of them will go on at the same time. There's two types going. There's the type I mentioned before, and then the new type, which I just showed you, and that's for the player bullets. Alright, so speaking of player bullets, we need to modify the player bullets creation to use the spawn pool. So now we need to, if we look at the update method, we actually create a new gameplay object for bullet whenever we create a bullet. But we actually want to use the spawn pool, so we do the same thing. Bullets.release. And it will release a bullet. We set all of its information, and then we add it to the player bullets list. Alright, everything should be good. It should be using the spawn pool now. We do not need player bullets to remove anymore. Alright, let's see what it looks like. Oh, I do create it, and there's one more reference to it here. I do clear it as well. Alright, so now I create the bullets, and it's using the spawn pool, and right there it just removed the bullets. Now, actually, the bullets are moving incredibly slow, so I'm going to update those. So what I'm going to do is I'm going to go into the update method when we actually create the bullets. I'm going to double the speed. Now, I'm going to also double the speed inside of the network data. That was actually the network data. I'm going to double it in the update method as well. So I'm going to double it in both places. Alright, that seems to be a little bit better. I might also increase the player speed. So I'm going to go ahead and probably double that. And you can increase the timer or decrease the timer, depending on which one you prefer. So the timer I gave for the shot seconds, it takes 5 seconds before I can shoot again. So I'm going to change that to 2. Let's see what that does. Alright, let's see about 1. Alright, so you can do all this stuff on your own, whichever one you prefer. You can make it not that bad. Let's try 0.5. Oh, I need to set F for float. Alright, so that's it for this video. I hope you enjoyed it, and I hope that we are now that we're using the SpawnPool, I hope that we are able to move along, and the next tutorial we will do the collision detection, and we'll go from there. So I hope to see you next time.